Hey guys, this is Alex, and today I'm going to be talking about covalent bonding from the IB Chemistry Standard Level Curriculum. And so we're just going to begin with the question, what is covalent bonding? And so our definition is that covalent bonds are chemical bonds between two atoms that involve the sharing of electron pairs. And so the first question to kind of really understand covalent bonding is, why do atoms share electrons? If we remember, ionic bonding was the electrostatic attraction between an anion and a cation, where the anion takes the electrons from the cation and they connect and bond because they have electrostatic attraction between the positive charge and the negative charge. And so the covalent bonds are going to be a little bit different in the fact that they don't have this complete transfer of electrons. There's not going to be an electrostatic force that joins them together, but rather they're going to share these electrons. And so this happens because nonmetals have relatively similar electronegativity values. And so because of this, they're going to pull on the electrons, and neither one of the atoms, because they're both nonmetals and have similar electronegativity values, are going to completely steal or rip away the electrons out of the valence shell and into their own valence shell. And so as a result, they're going to kind of share those electrons at about an equal rate. They're not going to all get transferred to one atom. And so the next question to understand how covalent bonding creates molecules is, how many bonds can one atom form? And so once again, the octet rule kind of comes back into play, and all atoms are going to aim to satisfy the octet rule, where it states that an atom wants to get 8 electrons in order to fill its valence shell. The only exception to this rule would be hydrogen, helium, where they need 2 valence electrons in order to fill their valence shell. It's called the duet rule. And so as a result of the octet and the duet rule, the number of bonds formed, number of covalent bonds formed, is going to be equal to the number of electrons needed to fill the octet. And so the best way to look at this is through a couple of examples. So we're going to look at methane and chlorine. And so our first diagram on the left of methane shows the electrons that are in between hydrogen and carbon that are shared. And so if you recall in the periodic table, carbon is going to have 4 valence electrons and hydrogen is going to have 1. And so because carbon is trying to satisfy the octet rule, it is going to have 4 covalent bonds because it needs 4 electrons to fill its octet. And so thus it's going to form 4 bonds, 1 with each hydrogen. And hydrogen, trying to fill that duet rule, needs 1 more electron, and it's trying to get to that full ring of 2. And so it's going to form 1 bond. And so we see on the right that these bonds are represented by dashes, and each bond is a pair of electrons. And so the hydrogen has 2 electrons that completes its valence shell. Carbon now has 8 when it's bonded with the 4 hydrogen molecules. And so the octet and duet rules are satisfied. And so next we're going to look at a chlorine molecule, which you remember is diatomic, meaning that it's going to bond to itself, along with hydrogen, oxygen, nitrogen, bromine, iodine, and fluorine. It is diatomic. And so both chlorine atoms have 7 electrons, and they're trying to fill their valence shell with 1 more electron to get that octet. And so they're going to form 1 covalent bond, and so it actually does it with itself, and both atoms share a pair of valence electrons, allowing both of them to have that full octet. And so as usual with chemistry, there's always some sort of exception to the pattern or the rule. And so for covalent bonding, the exception is dative or coordinate covalent bonding. And so this is a covalent bond in which both of the electrons originate from the same atom. And so I think that the best way to look at this is through an example, because the definition makes it seem kind of confusing, and I find that looking at kind of the reaction that shows this is super helpful. And so you see in the diagram below, we have an ammonia molecule, NH3, that has 3 single covalent bonds between the hydrogens and the nitrogen molecule, or the atom, sorry, and 1 lone pair of electrons. And so when it reacts with a proton or a hydrogen cation, same thing, it turns into ammonium, or NH4. But this hydrogen cation lost its electron, and it's only the nucleus. And so it's going to bond with the nitrogen, but both of the electrons involved in that single covalent bond come from the nitrogen lone pair. The hydrogen isn't contributing one of the electrons for that covalent bond. And so on the right in our ammonium, we have the 3 hydrogen bonds that were in the ammonia molecule, plus this 1 coordinate bond on the right that is both of the electrons from the lone pair and the hydrogen cation. And so, once again, the dative coordinate bonds are when both electrons originate from the same atom. And so we see that in the reaction of ammonia to ammonium. Thanks, guys, for watching this video. Hope you enjoyed it, and see you next time.